So I'm going to start catching up to you. I know you guys, they take a little longer than normal, so let me just start trying to catch up to you. Okay, so in this one, looks like your solution is the left side of a half, not including the half, since the inequality is strictly less than. Okay, any questions so far on our process from solving it to using that value as a boundary? Yes?
You have to check. Like x equals 1.
I did in my head. I quickly went 3.5, negative 3.5. So yeah, you do have to check in these questions. So great point. Remember, you may get a false answer. It may tell you something and it may not be true. So double check that they are correct once you start getting to this point of more than one absolute value. Okay. The reason we didn't have to check when it's just a constant is this is the absolute value graph. If you end up getting answers, then it's gone through 2 points. So either you get answers or you get no answers. It's either possible and you get 2, or impossible and you'll get none. What does it look like when it's impossible? Well, what if I said something like that? There's nowhere that that'll happen because these are all positives and this is negative. So that's an impossible, like this line which never crosses this absolute value here. Okay, so that's why I didn't double check when it was just numbers, because I know that it's going to either cross and work or not work at all. Okay, so this was the last type of absolute value question that we worked on. And this one involved the number lines. So when you had the 2 absolute values and a number, we couldn't shortcut this anymore. We had to break down and make number lines. So I'll go over the first one with you just in case you're a bit rusty. But basically the idea was to say, let's make a number line for the first piece, which is absolute value x plus 2. And what I'm trying to do is think about this graph if I didn't have absolute value. So if I just had it as x plus 2. Wow, that's a terrible x plus 2. Let me try that again. Okay, x plus 2. So on the number line, what would be my point of concern would be at negative 2. Because that's where the absolute value either kicks in or turns off. And same thing, I put another number line out here for x minus 1, and I'd be thinking about it at the point 1, because that's where it kicks in. That gives me these 1, 2, 3 regions where it multiplies it by a negative on this side, positive, positive, multiplies it by a negative over here, and does nothing over there. So that tells me about my 3 regions, 1, 2, 3, and I use those to figure out an equation. So in region number 1, both are negative, so it's going to be negative x plus 2 minus x minus 1 equals 3. For region number 2, it says that x plus 2 is positive, and subtract this. And in the third region, they're both positive, so I would end up with, for my third, I'd have x plus 2 plus x minus 1 equals to 3. Okay. So that was how we did it when there was no more shortcuts available. We have to do the absolute values, use the number lines with the constant. And again, this will work if you do it for all your other equations. It just takes longer to do. So here I'm going to get negative 2x. Let's see here, minus 2 plus 1 will be minus 1. So I should get x equals negative 2 for the first. Okay, and then on this one, I'm going to have x minus x, but, so that's gone, and I end up with 3 equals 3. And finally, let's see here, I end up with 2 x's, that'll be 1, so I get a value of x equals to 1. Okay, so let's talk about what does it mean. Well, first we have to double check and see that it actually works. So if I substitute negative 2, let's try them. So at negative 2 I get 0 plus 3. Yep, that equals to 3, so I'm good for this one. And let's try it at 1. I get 3 plus 0. So yep, that one works as well. What does this mean? What do you think that means? So in region number 2, it tells me that 3 equals 3. Connor, you want to take a stab at it?
Just wondering, in your equation it's x plus 2 plus x minus 1 is greater than 3. Do you test that or do you test the equality?
We're testing the equality because if we know where it's equal, then that's the boundaries between where something's greater and less, right? So if we know where the equality point is, one side of that will be less or greater. In this case, we're looking for greater. So yeah, we're still looking for boundary points. That's why I'm testing it versus the equality. But what does that 3 equals 3 mean? What do you think? Jackie, you... Parts of the graph overlap, just like when we looked at the systems of linear equations. So what part of the graph does this correspond with? So what values of x would that be? This equation came from region 2, yeah? Okay, so where is region 2? Region 2 is between these values here. So let's try one. 0. Okay, so 0 plus 2 plus 0 minus 1. So this will be 2 plus 1, that's a 3. That worked. Let's try another one in there. How about negative 1? Negative 1 plus 2, that's 1. Negative 1 minus 1, that'll be 2 when we take it, so 1 plus 2 is 3. Every single point in there overlaps. They're all going to be answers to this where they're equal to 3. So every value of the equation when x is from negative 2 to 1 equals 3. That's what it means when you end up getting equality there. There's overlap. The two are equal for every value in that region. Okay? So what we can conclude about it, we don't want them to be equal. We want them to be strictly greater. So we're not going to use anything there in that region. Okay? Okay, so I'm running out of space a little bit here. But I have my boundary points. My boundary points are going to be 1 at negative 2 and another at 1. And what we've just said is this is basically ignored. You got to pretend that's not even there because this isn't part of my solution. I'm not shading it in. I'm just saying ignore it because I know that that's where they're equal and I don't want them to be equal. I want them to be greater. Okay, so let's test some points. So for example, if I was to test x equals, oops, let's change it to black here. Let's say test x equals negative 5. So then I've got 3 plus 6, which is greater than 3. So it'll work everywhere which is on this side. Okay. And let's test another point, like say x equals 2. Then that means I'm going to get 4 plus 1, which is still greater than 3. So this part of it works as well. Okay, so that would be what my solution looks like in that situation.